So friends, here we have another very important question of JEE Advanced. Let us quickly read what the question says. A particle is moved along a path A, B, C, D, E, F, A. Here is a particle that is moved along A, B, B, C, C, D, D, E, E, F and again F to A. In presence of a force F that is given this, where x and y are in meter. So f is a function of x and y, and value of alpha is given this. So force is given, F is equal to alpha y I cap plus 2 alpha x j cap Newton, and the value of alpha is minus 1 Newton per meter. Okay. So we have to find the work done on the particle by this force F along this path. Fine. Basically, this question is testing your expertise in scalar product of two vectors. As you know, work done is the scalar product of force and displacement. This is the formula of work done by a force or displacement S. So now let us find the work done by F in this process. So first of all, particle goes from A to B. So work done by the force from A to B, what will be work done by the force from A to B? This will be F into S, F dot S. Let us simplify, put the value of alpha minus 1. So this will become minus y I cap minus 2x j cap. This will be the force vector. Now let us discuss work done from A to B. So from A to B, you can see the value of y is constant throughout A to B. This is y, and that is equal to 1 meter. This is 1 meter, and that is constant throughout A to B. So put the value of y is equal to 1. So F AB will be equal to minus I cap minus 2x j cap. As y is constant, that is 1, only change is in the value of x, that will go from 0 to 1. This is our FAB dot S. Displacement, what will be the displacement vector? This is positive direction I cap, positive direction I cap, magnitude will be 1 meter. So this will be plus 1 I cap. Now minus into plus, that will be minus I dot I, that will be 1. So this will become minus 1 minus j dot I, that will be 0. So work done from A to B, that will be minus 1 joule. This is our equation number 1. Now let us find the value of work done from B to C, that is WBC. So WBC, what is constant here? This value of x is equal to 1. This is constant throughout BC. So there is no change of x, that is 1 for B to C. So put the value of x is equal to 1. So force FBC will be minus yi cap minus x is equal to 1. So this will become minus 2j cap dot displacement. What will be the displacement vector? BC. See, this is negative direction, minus j cap, negative direction. And what will be the magnitude? This is 1 to 0.5, that is 0.5. So this 0.5 minus 0.5 j cap. Now what will be the product? See, I dot j, that is 0, minus minus plus 2 into 0.5, that will be 1, and j dot j, that is will also 1. So this will become plus 1 joule. That is equation number 2. Now we will find work done from C to D. WCD. Work done from C to D. So what is constant here? You know, this value of y, that is 0.5. This is constant throughout CD. So y will be constant, that is 0.5. Now put the value of y to find the force FCD. So this will become 0.5 I cap minus 2x j cap. Dot, what will be the displacement vector? CD. See, this is minus I direction. So negative minus I cap. And what is the magnitude? Magnitude is 0.5 to 1. Outside 1 to 0.5. That will be 0.5. So minus minus plus 0.5 into 0.5, 0.25. I dot I 1 minus minus plus j dot I, that will be 0. So this will become 0.25 joule for CD. Now let us find work done from D to E. D to E. W D E. So what is constant here? This is x is equal to 0.5. That is constant throughout D. So let us put x is equal to 0.5 in this. So the value of FDE will be equal to minus yi cap minus 2 into 0.5. Value of x will be constant, 0.5, 2 into 0.5, that will be 1, minus 1 j cap dot, what will be the displacement vector? D minus j direction minus j cap, and what is the magnitude? That is 0.5 meter. So this will be 0.5 j cap. Let us multiply. See, I dot j again 0. Now j dot j 1 minus minus plus 1 into 0.5, that will be 0.5, and j dot j 1. So this will become 0.5 joule. Now let us find the value of work done from E to F. W E to F here. What is constant here? The value of y is constant, and that is 0. You can see on x-axis y will be 0 from E to F. So y will be equal to 0 for E to F. Let us put the value of y is equal to 0 here. So force for F, E to F will be, this will become 0. So we are left with minus 2x j cap only. Value of this 0, y is equal to 0. Dot, what is the displacement vector? EF. This is minus I direction minus I cap, and what is the displacement magnitude? This is 0.5. This is 0.5 I cap. But you know, j dot I, that is 0. This is question number 5. Now work done from F to A. Similarly, what is constant here from F to A? That is the value of x. On a y axis, x will be 0 always. So x will be 0 for F to A, and constant. Put the value of x is equal to 0 and the value of vector force. This will become minus y I cap, and again x is equal to 0, so this will become 0. We are left with minus y I cap. And displacement vector Fa, this is magnitude 1, and this is positive direction plus j, so this will become plus 1 j. But again, you know, I dot j, that is 0. So work done here also 0. So work done will be 0 for A to F and also for 0 for F to A. Now what will be the net work done for the complete process? That will be W from A to B plus W, B to C, W, C to D, W, D to E, W, E to F, and finally W, F to A. So WAB, that is equation number 1 minus 1. WBC, equation number 2 plus 1. WCD, equation number 3 plus 2.25, 0.25. WDE 0.5 plus, this will be 0.5 plus WVF is 0 and WFA is also 0. So this will be 0 plus 0. Now 1 cancel out. So the value of work done will be 0.75. This was our required answer. I hope you got it. Basically that was very simple question. Only you have to take care of the direction and magnitude. Basically direction, like here it is positive, here it is negative, again negative, again negative, again negative, then positive. Rest everyone knows. I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1, I dot j is equal to 0, j dot k 0, k dot I that is 0. So basically this was a very simple but very conceptual question, and you can solve it in hardly 20 seconds. Thank you.